Okay. Okay, hello everyone. So today I'm gonna solve question 3 of homework 2, possibly the most difficult question in this homework. Okay, so we are in reference dependent utility. So let's begin. So let me read the question again. So question 3 of homework 2 says that, let me use a thick one. Okay, so suppose, so one is randomly assigned a mark, and then the other is not. And then in this question, we are in the shoes of the seller. Okay, and then the seller is told that with a probability of P, the exchange will be forced at price X, and then let me use color blue. With probability 1 minus P, they have autonomy to decide. So if seller doesn't sell under autonomy, then they face stochastic reference point, this one. Okay, so this is given. Let me use color red. So this reference point is given throughout this question. Okay. So if they're forced to trade the mark at this fixed price X, then for the seller, he will end up with 0 mark because he sold the mark, and then he will get X dollars. Yeah. So the first argument here, this 0, this first argument stands for the mark. The second argument is the money that he gets. And then because he decided not to sell the mark, if we fall into this autonomy case, he has freedom to choose, freedom not to sell the mark. So he will keep his mark, 1 amount of mark, and gets 0 amount of money. So this is our reference point. Any questions? Okay, so I guess everyone understands the setting of this question. Now let's dive into question A. Show the reference dependent utility, Kozagi-Rabin preference of not selling the mark. Let me highlight this. Not selling when under autonomy is this one. So the answer is given. So our professor was very, very kind to give the answer to us. Okay. So we want just to remind you of the notation. This big U is the utility. And then we have, let me write it as not selling. Under autonomy. And then this line, this vertical line stands for, so this one is to separate my action and then my reference point. So my reference point comes here. P, I made a typo here, so sorry. If you see this orange box, I made a typo, it should be times, P times 0x plus 1 minus P times 1, 0. I'm sorry. Yeah. So in the lecture note, in the homework, I should be correct. Yeah, it's just my typo. Anyway, so let me write reference point like this. So step 1, let us think about the easy one, the consumption utility. And then step 2, we'll think about the gain and loss part. Consumption utility, it was something like M something. So M, first argument, second argument. Okay, so this part. So we are using expected utility here to compute this consumption utility. So by, let me write in English first and then write with equations. By probability, so this prop dot means probability. By probability P, his utility is, so he is ending up with 0 mark and X amount of dollars. So his utility is X. And then by these two dots, dot, means same thing as the line above. So by probability 1 minus P, his utility is 1. So adding up all of these in math with equations, we can write it as P times X plus 1 minus P times 1. So 1 minus P times 1 is just 1. So let me just delete brackets. So this is his consumption utility. I wrote it above, so yeah. So this Px plus 1 minus P is his consumption utility. Any questions? Let me make a horizontal line here to separate step 1 and step 2. Okay, here. I should have made more space. Well, let's see if I can cramp all the answers here. So step 2, gain loss part. Gain loss. Okay, so same thing by probability P. Let me make a line like this. By probability 1 minus P. So by probability P, now I'm forced to trade. Okay, and then there are two outcomes here. I was expecting, so we're comparing state by state. I was expecting, again, by probability P, I was being forced to trade. And then in this case, my outcome was 0, X. And then by probability 1 minus P, I'm in the autonomy case. My outcome in this case is 1, 0, 1 mark and $0, no trade. Okay. Yes. So in this case, no trade. So in this case, here, if I'm forced to trade, then my outcome and then my actual outcome and then my expectation is the same. Okay. So outcome and my expected outcome, expectation is the same. So it should be so my gain and loss is 0. Okay? So there's my expected outcome is the same as the actual outcome. So there's nothing, no gain and no loss. So this is the only case that I need to consider. Okay. So in this case, let me move this one here. So in this case, the initial probability was P. Okay, so I was forced to trade. Okay, and then times 1 minus P within this state, I was expecting by probability 1 minus P, and then we multiply by eta to represent gain loss utility. And then we state the value of utility here. So what did I gain and what did I lose compared to my reference point? So in this case, my reference point was having 0 mark and then X dollars. However, what I expected was having one amount of mark and then having $0. So this part is gain, and then minus lambda times 1 is my loss. Okay, so I was, I'm sorry. So lambda times 1 is the amount of mark that I feel as a loss. So this part is a loss. This part is gain. Okay. Any questions? If there's no questions, let me move on. So same thing. In here, we fall into autonomy case. And then if I fall into autonomy, I was expecting no trade. So yeah, this one is the outcome. And then let us compare with the reference points. So by probability P, we are forced into the trade. We get outcome 0 and x, which is different with the actual outcome. With probability 1 minus p, I fall into autonomy where the outcome is 1, 0. So in this case, outcome and the expectation is the same. It's the same. So there's no gain and loss. This part is what we want to consider. So this part happens with probability 1 minus p first, and then multiply by p times eta to consider the gain loss utility. Now let's see what we have here. Let me erase this to make it cleaner. So one is the actual outcome, that what I have. So, and then in here, 0, x is my reference point. So compared to my reference point, I gained 1 mug. However, I expected X amount of dollars, but I do not have it right now in my outcome, in this autonomy case, in this purple arrow. So this is my loss. So I feel like I lost X dollars. And then to emphasize this loss, we were multiplying by lambda. Any questions? Does it make sense? Okay, so we compared state by state. If outcome and the reference point is different, remaining thing to do is to aggregate. I mean, add. So aggregate is too fancy. Add. Okay, so the first part was p times. Let me just highlight this part. If you see this part, p times 1 minus p times eta is common to both the line above and line below. So I can just factor out with this term, right? So keep that in mind. 1 minus p times eta. And then I just need to add x minus lambda plus 1 minus lambda x. Do you see what I'm doing here? I was adding the terms in this purple circle. Okay. So I just need to rearrange, clean up the line above. We have 1 plus x minus lambda, 1 plus x, right? So I was collecting 1 plus x to the first, and then I was factoring out with lambda, pull it out to the front, then I will have 1 plus x. Does this make sense? If I'm going too fast, then please let me know. I may go fast because I was practicing this like 3 or 4 times. So if I'm going too fast, then please let me know. When I was solving this for the first time, of course, I was not solving at this speed. Anyway. Yeah, so we can see that 1 plus x is common here. So I can also pull out that one. And then we have 1 minus lambda. Yeah, because this first circle that I'm circling right now, this is 1 times 1 plus x. The second one here is lambda times 1 plus x. So if I pull out, if I factor out with 1 plus x, then I will have 1 minus lambda here. Any questions? Then we are done. This is not a very good presentation, but let me put step 3 here. Then we just need to add consumption utility and the gain loss utility. So add everything. Then our answer will be p times x plus 1 minus p. Oh, I was reading here. Yeah. So, yeah, I was reading this part of step 1, the consumption utility. Plus p times 1 minus p times eta plus, I'm sorry, times 1 plus x, 1 minus lambda is our answer. The second part comes from, our step 2. And then, it looks, it's the same as the answer. Okay, any questions? Okay, so this presentation is not good. It was going into like this counterclockwise direction, but I hope you understand. This one is much more simpler, so I can put everything into this space. So this question is asking us, let me just go back to color blue. So we are still computing reference dependent utility, of selling. So the case above was not selling, and then this case is selling the mark under autonomy. And then the answer is this. Very nice. So in this case, so let us do it in a similar way. Step 1. We want to compute consumption utility. So not the gain loss utility, just the value of this action itself. So let me approach in a similar way by probability P. What is the outcome? So by probability P, then my outcome is 0 mark and X dollars, right? So outcome is 0 and X, and then my utility in this case will be X. So this dot dot, 2 dots means same as the line above. By probability 1 minus P, my outcome is 0 and X, and your utility value is, everything is the same, X. So in this case, if I fall into autonomy, I decided to sell the mark. So if I'm forced to sell, or if I'm going to sell under autonomy, I'm selling in any cases. So my outcomes will be the same, right? So in this case, we have same outcome. So what is my consumption utility? Consumption utility is P times X plus 1 minus P times X. You don't need to think in this way. Outcome is the same in every case. So it should be just X. Okay. So this part on the line was kind of verbose. Don't need to think in this way. It's just X. Any questions? Let me put step 2 here. So also the counterclockwise way. Now let's think about gain loss utility. And then we want to specially focus on when does the outcome be different with my reference point, what I expected. So by probability P, so let me do it the same way, by probability P. So this is the case where I am forced to sell the mark. And then what happens here? Now this part is related with my reference point. Okay, so be careful. So with probability P, I was expecting to sell the mark because I was forced to trade. I was forced to trade. So before I was into this game, I was thinking that I am forced to trade. And then my outcome, I will be left, after this experiment, I will be left with $0 because I sold the mark, and then I get X dollars. So in this case, is the outcome same as the reference point? If I'm forced to trade, my outcome is this. So yes, the outcome in my reference point is the same. So no gain loss. Oh, am I going too fast? Is it okay? Okay. Let me move on. And then with probability, with a probability 1 minus p, I was in the autonomy, as I expected to be in the autonomy case. I expected to not sell the mark. Okay, so because this, remember, this one is our reference point. So I was thinking that I was not gonna selling the mark under the autonomy case. So my expected outcome, my reference point was 1, 0. Because I didn't sell the mark, I didn't get any money from anyone. So now we have gain and loss. So P times 1 minus P. This P comes from here. This 1 minus P comes from here. And then let me multiply eta for gain loss. Let's see what is gain and what is loss. In here, I was expecting 1 mark, but I end up with 0 mark. Okay, so 1 loss of mark minus lambda. And then I got X dollars. This is my gain. Does this make sense? Go back, go back, go back. Let me write it again. So I got X dollars, lost 1 mark. Okay. And then, do you see what is happening here? By probability 1 minus P, we are in the autonomy. But in any cases, I'm ending up with outcome 0, X. And then, it's the same. P by probability P now, this is happening in my mind, okay? My reference point. I'm forced to trade. I'm having 0, X, which is same as my outcome. So there's no gain and no loss. 1 minus P, I'm in the autonomy case. We have 1. So now we have outcome which is different from my reference point. So my utility in this case will be P times 1 minus P. I'm sorry. Oops, 1 minus P times 1 minus P times eta. Maybe I was too fast here. So this first 1 minus P comes from here. This 1 minus P comes from here. Okay. And then what is my loss and gain? It's actually the same as the case above. So I got X dollars. Let me use different color. I got X dollars. This is my gain. And then I lost. It feels as I lost 1 mark. So minus lambda. But you can see that this part is the same, right? So if I add up everything, let me write step 3. Add everything. Consumption utility was X. My gain loss utility is P times 1 minus P times eta X minus lambda. This one. I was reading here. I was putting it here. And then we add 1 minus P eta X minus lambda. But as I said before, this part is the same. So I can just factor out as X plus P plus 1 minus P. So adding the terms at the front times 1 minus P eta X minus lambda. This one is confusing. X. Okay, so this one is multiplied. not X dollars. Any questions? All right, so the long story short, the answer is X plus, if I add everything in this blue box, it will be just 1. So I will have 1 minus P eta X minus lambda. Is the answer looks correct? Okay. Any questions? Okay. So we are done with question A and B. Let me go to question C. So take eta equals to 1 and lambda equals to 2 to simplify. Write down the inequality condition for not selling under autonomy to be a personal equilibrium. Yeah. If I go back to question B, so this one was utility under, what was this? Selling under autonomy bar. So this bar is separating out my action and my reference point. And then my reference point was P 0x plus 1 minus P 1 0. Okay, so we are comparing two things here. So not selling under autonomy to be a personal equilibrium. So we want utility of not selling. Now let me just write it as not selling. Okay, so it should be not selling under autonomy, but let me just write it as not selling with this reference point. Should be larger. So I need to prefer this one. U of selling under autonomy. P0x 1 minus P 1, 0. So we need this inequality, right? So let me just copy and paste my answer from above, and then we are done. Does this make sense? Okay, so we need this one. Copy, paste. Delete this one. Should be larger than. So this was the utility. I mean, this left-hand side was the utility of not selling the mark under this blue reference point. And then for the right-hand side, we just copy and paste the answer from question B. It is here. Copy, paste. So yeah, we are done. This is our inequality. Any questions? Okay, so the final piece of this question is asking us to solve for x to show that the maximum price at which the seller doesn't want to sell the mug in equilibrium is this value. So what we want to do is to before moving on, there was a question. So Jose was saying, yes. So we need to plug in everything. I mean, do you mean we need to plug in here like this to make this inequality? Yes. So let me be clear. Yeah, good question for where we are going. So this is answer from question A, and we are plugging in the answer from question B. So this is not selling. This is sell, of course, under autonomy. And then in question D, now we are using this inequality. So we are going to use it here and then solve for x. So solve for x. When you see something like this, This means that we want to isolate x in one side, left-hand side or right-hand side. So our final, because in this question, the professor was giving so many hints. He was asking about maximum price. So it means that x will be less than some term. Okay, so our answer gonna look like this. So x cannot go beyond this value. So let's see if that happens. So keeping that in mind. Yeah, so if it reach to the final answer, it will look like x is less than 3 minus p over 2 plus p. So this is our SP bar. So let's see if it happens. So first, let me just write the inequality above in one line to make it clean. So this part is actually not that much economics here. It's just algebra. Okay. So let me put x in one side. So let me collect x here first. X at the left-hand side. X p. So this first p comes from here. We have another ugly terms here. So let me write it. P 1 minus p eta 1 minus lambda, and then put the remainings here. 1 minus p plus p 1 minus p eta 1 minus lambda. If I make any mistakes, please let me know. Same as the left-hand side, let me collect x at the right-hand side. Let me write what I'm doing here. So this step, collect x in each left-hand side and right-hand side. So we have 1x here, 1. And then we have plus 1 minus p eta minus 1 minus p eta lambda. Okay, so we are separating x and then terms remaining. Any questions? Okay. Oh, I forgot to close brackets here. And then let me move everything to the left-hand side. Moving to the right-hand side is much more easier because the final answer should be x should be less than blah, blah, blah. So let me move everything related to x to the right-hand side like this. So either way, you will get the same answer. I think I wrote the answer key to move to the left-hand side, but yeah, you will get the same answer. So this step, every term related to x to RHS, remaining terms, remaining terms to left-hand side. So I'm going to do this. So at the left-hand side, we have 1 minus p, 1 minus p, eta 1 minus lambda left. Okay. And then minus plus 1 minus p eta lambda is less than, is greater than x 1 plus 1 minus p eta minus p 1 minus p eta 1 minus lambda. Oh, I hope I don't make any mistake here. And then in here, now next step, you can see that this 1 minus p is common to every terms here. So let me factor out with 1 minus p. We have 1 plus p eta 1 minus lambda plus eta lambda. Okay. Is greater than. I was stupid. In this question, eta is 1 and lambda is 2. So I should have okay. So what Jose was asking was that we need to substitute eta equals to 1 and lambda equals to 2 in this inequality. Yes, right. Now I understand the question. I'm really sorry. Let's do it now. So it was much more difficult than I thought. Okay, so let me do it now. I'm really sorry. Okay, so substitute eta equals to 1 and lambda equals to 2. Let me refresh. Should have done earlier. You're not wrong if you do it like this in the exam, but it's gonna make your life much more difficult. Okay, so here we have 1 minus p plus p 1 minus p. Eta is 1, lambda is 2, so we have minus 2 here, plus 1 minus p times 2. Okay. And then x. So I'm just substituting eta equals to 1, lambda equals to 2. That's all I'm doing here. 1 plus 1 minus p minus p minus p 1 minus p 1 2. This one becomes positive. Okay. And then at the left hand side we have 1 minus p and then we have 1 plus 2 minus p. So in the left hand side, everything has 1 minus p. So I was factoring out with 1 minus p. Okay. And then here we have, you can see that this one, color blue, this one combined is 1 minus p. We have another 1 minus p here. So we have 2 1 minus p plus p 1 minus p. Right hand side is 1 minus p, 3 minus p, x 2 plus p, 1 minus p. So x should be, let me reverse the inequality. So x comes here. 1 minus p, 3 minus p over 2 plus p, 1 minus p. Is it correct? And then finally, we can cancel out 1 minus p here because it is common at the numerator and denominator. So this is 3 minus p, 2 plus p. This is what the question called as S bar p. Yeah. I'm sorry for making this too much difficult. It shouldn't be. We should have substituted eta and lambda, as Jose said. I'm sorry for this mistake. Yeah. So let me be clear here. So here the answer, the correct answer. So I was wrong. I mean, not very wrong, but yeah, I should have put eta equals to 1, lambda equals to 2 here. So the answer, simpler answer will be px plus 1 minus p plus p 1 minus p 1 plus x minus greater than x plus 1 minus p x minus 2. So if you started with this inequality, it should have been much more easy. Okay. Write it here, easier. Okay, so this is what I prepared for today. Thank you guys for coming. Let me end the section early again. If you have any questions, please let me know. Let me stop recording.